Welcome to this predicted paper from On Maths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our On Maths site. On Maths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. So the only way of answering this question is to work out what these are as ordinary numbers. And so 7 times 10 to the power of 7 would be 7, 1, 2, 3, 4, 5, 6, 7. And 9 times 10 to the power of 4 would be 90,000. So that would be 9, 0, 0, 0, 0. And so we're just subtracting them like that. And so we'll get 6, 9, 9, 1, 0, 0, 0, 0. And obviously if this is on the calculator paper, just type it into your calculator. There are no tricks here. You can't do anything with the 7 and the 9. You're not subtracting powers or anything. You're just literally typing in what it says. And there's a button on the calculator like that that you will need to use. So if you don't know what that is, ask your teacher or ask someone to help you out with that. So I'm going to start just by writing out the equation, and I can put my lines in. Okay, we're asked to make x the subject, so we're going to first of all add 10 to both sides. In fact, I'm just going to move all this over a little bit so I've got a bit more space. Okay, so we're left with m plus 10 on the left hand side, and we've got 1/7 x on the right hand side. Now to get rid of the 1/7, what I can do is just times both sides by 7. So 7 brackets m plus 10 equals x. So x therefore would equal 7 brackets m plus 10, but it says to expand your answer fully. So we're just going to expand the brackets, 7m plus 70. So this question says that Adrian, Ben and Charlie have some sweets, and the ratio of Adrian to Ben to Charlie is 9 to 6 to 13. But it also says that Charlie got 56 more sweets than Adrian. So there's 56 more sweets. Well, looking at the actual parts of the ratio, there are 4 more parts. So plus 4 parts, which represent plus 56 sweets. So the 4 extra parts are worth 56 sweets. So 4 parts are worth 56 sweets. So 1 part would be 56 divided by 4, which is 14 sweets. So all we need to do now is work out how many parts there are. Well, there are 9 plus 6 plus 13 parts, which is 28. And each part is worth 14 sweets. So the total number of sweets will be 28 times 14. So 28 times 14 is 392. To find the exterior angle of any polygon, we do 360 divided by the amount of sides. These are decagons, which means they have 10 sides. So the exterior angles will be 36 degrees. And the exterior angle is just an angle that kind of continues on. You just continue on from the side. So this one here is the exterior angle of the left-hand decagon. And this one here is the exterior angle on the right-hand decagon. So altogether, the angle A will be 36 plus 36, which will be 72. So our answer will be 72 degrees. So we know that James knows that he has a square. So we can actually get rid of all of this bit. It's not relevant at all to the question. And the question asks, what is the probability that the square is blue? Well, there are 3 blue squares, so it will be 3 over, and how many are there in total? Well, it says the total is 17. So the answer is 3 over 17. To find the smallest possible width, I'm just going to do a quick number line, and all I'm going to do is put 12.2 on our number line and figure out what the next number down will be. Well, if it's the nearest tenth, the next number down would be 12.1. That's the next number down it could have rounded to. And I'm just going to cut this number line in half and find out where our halfway point is. Well, the halfway point would be 12.15, and that's actually the minimum it could have been before it would have rounded to 12.1. So angles on a point add up to 360, and we are given the values of the angles but in terms of r. So we know that r plus 9r plus 20 will equal 360. So we've got an equation here we can solve. So first of all, let's add the r's together, and so that will be 10r plus 20 equals 360. Then we're going to subtract the 20 from both sides. So we have 10r equals 340, and then we're going to divide by 10 both sides. So we have r equals 34. So our answer is 34. So when you read this question, the question's basically asking you to find the bearing of O from B. So the lifeboat is at B, so I'm going to draw a north line here. And to find a bearing, you start from the north line and you keep going clockwise. So we're going to look for this angle here. Now, this angle, which is given to us in the question, and this angle here, which I'm just going to call x, are going to be equal. So x is going to equal 135 degrees. And the reason for that is we've basically got, and I'm just going to draw or extend the north line down, because we've basically got we have a set of parallel lines here, and we have a set of z angles, which we know is alternate angles. So the reason for that is it's alternate angles. And always show the reasons to the examiner. Okay, and so to find out what the bearing is, so the bearing of O from B, it's just going to be 360 take away 135, and the reason for that is angles on a point. We've run out of space. Okay, so we're going to do 360 take away 135, which is 225, and so our answer is 225. So the first thing we need to do is work out the mean for the data in the table. So to start off doing that, we're going to work out the midpoint of each group. So we've got 80 to 85, and to find the midpoint, you add the 80 and the 85 together, then you divide by 2. So this will be 82.5, then 87.5, then 92.5, then 97.5, and then finally 100 plus 105 divided by 2 is 102.5. Next we need to find the FT, which is just the frequency times the duration of calls. Now, in this first group, we're not timesing it by 80 to 85 or anything like that. We're timesing it by the midpoint. So our midpoint effectively becomes the T. So we're going to do 15 times that, which will be 1237.5. And we're just going to keep going and multiplying each of these together. And then finally 2050. Right, next we need to add up the frequencies and add up the FTs. So we're going to have the sum of the frequencies. So I'm just adding all this column up, and that will be 80. And we have sum of the FT. And so we're going to just add this column up here. And so that would be 7,450. So what this column represents is all the numbers added up together. This column represents how many numbers we have. So to find the mean, it's all of the numbers added together, which will be 7,450, over the amount of numbers we have, which is 80. So when you do that, we get 93.125. Now this question is about the improvement that we've made, or that the manager has made, the call centre's made. So we're looking at subtracting the 93.125 away from the last week, which was 105. So we're looking for improvement. And we're going to do 105, take away the 93.125. And that's going to be 11.875. Now it does ask for 2 decimal places, so that will be 11.88. So if we imagine we've got the 25 meter pipe here, and we've got the 35 meter pipe here, the question's basically asking us what can we cut all these pipes into, and they all have to be the same length, that will fit with the 25 meter and the 35 meter. And essentially what this question is asking is, what is the highest common factor of 25 and 35? So to find the highest common factor, what we do is we just find the factors of 25, which is 1 and 25 and 5 and 5, and the factors of 35, which will be 1 and 35 and 5 and 7. And the highest common factor is the number in both lists, the highest number in both lists, so it's 5. So what we can do is we can cut all of these pipes into 5 meter pipes. So 1, 2, 3, 4, not to scale, and then 7 of these, so 1, 2, 4, 5, 6, and so there's 7 in total. So each of these are 5 meter long, and there's no wastage, and that's the longest we can make the pipes for there to be no wastage at all. So my answer is 5 meters. So to find the area of a rectangle, we do length times the width. So here, to find the area, we will do the 10 times the whole of the 10t plus 4. And to show that we're doing the whole of it, we put it in brackets. So a different way of writing that is 10 brackets 10t plus 4. And whichever method you use to expand brackets, feel free to do it here. I'm going to just do the grid method, but whatever method you prefer. Actually, I don't need the, I've done too many here. Let's get rid of that. So we've got 10 times 10t plus 4. So we're timesing them, so 10 times 10t, 10 times 10 is 100, so it'd be 100t, 10 times 4 is 40. So our answer will be 100t plus 40. So in this question we are told that the centre of enlargement is at 6, 4. So let's just put across there. And what I'm going to do is just draw ray lines from the centre of enlargement, and we're just going to go through each of the corners of our shape A. And we're going to just check whether it goes through the corner of shape B, which it does on this one. Let's just keep going. Yeah, it does on this one. But it does not on this one. So it says find the coordinate of the vertex of shape B that is not correct. So the coordinate is this one here, and so that would be -4, 1. So I'm just going to write this out a little bit bigger, just so we've got a bit more room to play with. And I'm going to start by putting my tramlines in. Anytime it says solve, I always put my tramlines in. We can start by either multiplying out the bracket, or we can be clever and just divide by 5s both sides. And that'll leave 6x minus 39. And 15 divided by 5 is 3. Then I'm going to add the 39 to both sides. And so we've got 6x is greater than or equal to 39 plus 3, which would be 42. And then we're going to divide by 6 both sides. And we've got x is greater than or equal to 7. To find the gradient, we need to find 2 points we know on this graph. So I'm going to pick that coordinate and this coordinate here. And we know that we need to draw a right angled triangle between them. And we find the gradient by the change in y, which is 3, over the change in x. But notice the change in x is 1, so it's going to end up being 3 divided by 1, which is just 3. So a different definition of the gradient is for every 1 we go to the right, how far up we go, which is 3. So we're asked to find angle BCE, and that is going to be this one here, because you start at B, go to C, and then go to E, and it's the angle you make. And I might just choose a different colour because we've already got red on here. So we're looking for this angle here. Now, my advice for these kind of questions is always just try and work your way around the shape with angles you know. So, for instance, I'm going to start with this angle here, and we're going to call this angle ADC. And we know that that must be 79 degrees. And always write down the reason, and we know it is because that is an isosceles triangle. So if you look, we've got an isosceles here, this one, and this one. And the bottom two angles, and I use the word bottom because I always imagine an isosceles as being this way up. The bottom two angles in an isosceles are always equal, so that must be 79. Now we've got 2 of the 3 angles in the triangle, and the last one is going to be angle DCA. And to work out what this angle is, we're going to take it away from 180. So we're going to do 180, take away the 279s we've just worked out. And the reason for that is angles in a triangle equal 180 degrees. Okay, so when we do that, we do 180, take away the 158, and we're left with 22 degrees. So we know that this is going to be 22 degrees. And now we can actually work out angle BCE, because it's going to equal angle DCA. And the reason for that is they are vertically opposite angles. So that's just going to equal 22 degrees. Now, it is really common for these types of questions for you to get maybe 1 or even 2 marks for the answer, but 1 or 2 marks normally for the reasons and for the explanations. In fact, I've seen quite a few exam questions where you get 2 marks for the reasons and only 1 mark for the answer. To solve this, we've got to first of all factorise the left-hand side. And so we look at the number, and it's definitely a difference of 2 squareds. So x squared the square root of that will be x. And we think about what the square root of 144 is, which is 12. And so we plus 12 and we minus 12. So difference of 2 squares, you take the positive and the negative root. Now to solve, one of these brackets is going to equal to 0. So we're going to do the first bracket equal to 0. So we've got x plus 12 equals 0. And we're just going to put our lines down and take away 12 both sides. And we get x equals minus 12. So one of our solutions is minus 12. And we do exactly the same thing to the other bracket. So get it equal to 0 and solve. So add 12 both sides. You'll notice something about the numbers here, that they are just exactly the same. And that's because that when you find a solution, you get the number here and you just change the sign. So that becomes minus 12 and that becomes plus 12. So the first thing I notice is the second equation isn't really in the normal format for doing simultaneous equations. So I'm just going to rearrange it so that we have it where we want it to be. And I'm just going to put my lines in so I can rearrange. So the first thing I want is the x's and y's on the same side. In fact, actually all I need to do is take away 4y from both sides, and we get 5x minus 4y equals minus 7. Okay, so what we do now is we put both our equations down so we can solve these simultaneously. So 5x minus 4y equals minus 7. And you notice the coefficient of the y is already the same, so we don't need to multiply anything. But the signs are different, and the d in different is the d in add. So we're going to add going downwards. So we're going to add everything. So we're doing 3x plus 5x, which is 8x. 4y plus minus 4y is nothing, which is good, because we want to get rid of that. And 47 take away 7 is 40. Alright, let's put our solving lines in. And we're going to divide by 8 both sides. So we get x equals 5. And we're going to substitute that value into one of the equations. I'm going to pick this top one. So instead of 3x, we're doing 3 times 5 plus 4y equals 47. Get my solving lines in. So that will be 15 plus 4y equals 47. And then we're going to take away the 15 both sides. And so it's 4y equals 47 take away 15, which is 32. Divide by 4 both sides, and we get y equals 8. Now we can check that using this equation here. So 5 times 5 is 25. Take away 4 times 8, which is 32, is minus 7. So we know we've got it right. First thing we need to do is work out the volume of this prism. And it's a trapezium-based prism. So the volume will be the area of the cross-section, or area of the trapezium, times the length, how 3D the prism is. So trapezium is half a plus b h, and then times the length. Now a and b are the two parallel sides, which will be this one and this one, and then the h is the perpendicular line that hits both of them at 90 degrees, which is what perpendicular means, between the bases. So this will be the 25 meters here. So it's going to be half, and then we're going to add 1 and 5, times that by 25. The length is how 3D it is, so it would be that 10 there. So we're going to times that by 10. And that will give us 750. So it's 750 meters cubed. Now, there is a little formula we can make for the rate. So the rate of anything for this will be the volume gained over time. Now, with this question though, we're interested in the time it will take. It says how long will it take. So we're actually looking at the time. So it will be time equals the volume, which is 750, over the rate, which is 15. So 750 divided by 15 is 50. So it will take 50, and let's have a look. It says per minute. So it would be 50 minutes. With these questions, it's normally easier to view these as two separate triangles. So we've got a small triangle here with 19 and 47. And what I'm going to do is I'm just going to move this out. And we've got a bigger triangle here. And we've got, well, we've got a bit of, we don't really know what any of the sides are just yet, but we can work them out. Okay, now we know that both of these triangles are similar, and the reason is they share an angle and the lengths at the bottom are parallel, so they will be similar, which means one's an enlargement of the other. And we are given some information in the question that the ratio of BC to DE is 1 to 6. So BC is this length here, and DE is this length here. So we're actually given the scale factor because we know that 1 times 6 is 6. So we know the scale factor is 6, and it's asking us to find length AD. And so the corresponding length to AD, which is this one here. So all we need to do is get that 47, times it by the scale factor, so times it by 6 to get to our value. So it's 282. So we're going to first of all draw a tree diagram for this information. You don't have to, but it is easier to understand what's going on. And so the first choice will be the first pick. It'll either be male or female. And the second choice will be the same, male and female. And looking at the questions, there are 3 male names in the hat and 5 names in total. So the fractions for the first one will be 3 over 5. If there's 3 male names, there'll be 2 females. Now, if we've picked a male name already, there'll be 2 left and 4 left in total. If we haven't picked a female, there's still 2 females, but there's 4 left in total. If we picked a female, there'd still be 3 males and only 4 left in total, but there'd only be 1 female left. 1 female name left and 4 left in total. Okay, we're looking for the probability that the genders of the names are different. So looking at the outcomes, the outcome here would be male-male. That's not what we're interested in. Here would be male-female, we are interested in. Female-male, we are interested in. And female-female, we're not interested in. So we're not interested in these ones. And the way that tree diagrams work is as you go along the tree, any fractions you go across, you multiply together to find the outcome. So this will be 3 over 5 times 2 over 4. And I realise I could cancel 2 over 4, but I generally cancel at the end. So 3 times 2 is 6, 5 times 4 is 20. We're going to do the same with the other root. So 2 over 5 times 3 over 4. So 2 over 5 times 3 over 4, 3/4. That would be 6 over 20. Now we're looking to see whether it was male and female or female and male. And the word or in probability means add. So it'd be 6 over 20 plus 6 over 20. And this is the probability of different, which will be 12 over 20. Now 12 over 20 will cancel to 3 over 5, or 3/5. So we need to first of all work out what the length of the side of the square is. And to do that, what we do is we get the 44v to the power 4 w to the power 5, and we just divide it by 4. And to do that, all we need to do is just divide the coefficient by 4. So it'd be 11v to the power 4 w to the power 5. Some people will try and do something with the v to the power 4 w to the power 5, but if you think about it, if I just draw out my square, if it's 11v to the power 4 w to the power 5 all the way around, when you add, you don't add the v to the power 4 w to the power 5, it's just going to be 11 lots, another 11 lot, another lot of 11, and another lot of 11. So it's 44 v to the power 4 w to the power 5 in total. And to work out what the area is, we obviously are going to square that. So we're going to do 11v to the power of 4, w to the power of 5, and we're going to just times it by itself, which is what squaring means. Okay, so we're going to times the 11s together, so that's going to be 121. Going to times the v to the power of 4s together, and remember with indices, if you times two powers of the same base, and they're both v, then we just add the powers together, so that'd be 8. And we're going to add the w to the power of 5s together, so that makes 10. So it's 121, v to the power of 8, w to the power of 10. So the way this formula works is we have m, which is the final amount. The 2000 here is our initial amount. The decimal in here is our multiplier, and the power here is the amount of years. So the way multipliers work is they are the percentage divided by 100. So if we go the other way and times it by 100 to make it back into a percentage, it will be 102.9%. Now it says, what is the interest rate of the bank? Well, the interest rate is always going to be 100%. Well, this 102.9% is 100% plus the interest rate, which will equal the 102.9%. So the interest rate is going to be the 2.9%. You always start off with 100%. So if I put £5 into my bank, I've got 100% of that £5, and then the interest rate is on top of that 100%. So our answer here will be 2.9%. We don't have to for this question, but it might be helpful to draw a Venn diagram for this. And we've got green and brown leaves. So we'll have green on the left and brown on the right. So green and brown. And we're told that there are 19 green and 15 brown and 6 that were not green and brown. So the only number we can put in is the 6 on the outside of the Venn diagram. We're told that 19 are green, but we don't know which, either they're in here or a bit of both. So what we can do is we can label the center X, and we can say that there are 19 take away X just green, because they could have been both green and brown. And for the brown we can do the same, so it'd be 15 minus X. And for the next step, we know that all of them together add up to 32, because it says in the question. So we're going to add all of these, the 19 minus X, the 15 minus X, and the 6 together, and we know that equals 32. And let's get our solving lines in. So we've got minus X and minus X, so that's be a minus X. And we've got 19 plus 15 plus 6, which will be 40, equals 32. We're going to take away the 40 both sides. And we can just times by minus 1 both sides to make them both positive. So now we know X is 8, we can start filling in the Venn diagram. So it's 19 take away 8, which will be 11. X is 8, so we know that that's 8. And 15 take away 8, which is 7. So find the amount that were green and brown. We know it's going to be 8. With this question, you've just got to know what the different functions look like. So with C and D, we've got quadratic functions. One's a positive quadratic, which is a U shape. One's a negative quadratic, which is a kind of upside down U shape or an N shape. And here we don't have that, so we can get rid of those in our thoughts straight away. A is a positive cubic, which goes up, then down, then up again. And B is a negative cubic, which goes down, up, and then down again. So this one here goes up, down, up again. That's going to be a positive cubic. So our answer is A. So we're going to start by doing a grid. a multiplication grid, and we're going to start by putting 2x plus 11 at the top and 5x plus 3 down the side. And we're going to multiply them out, so 5 times 2 is 10, so it'd be 10x squared. 5x times 11, so 5 times 11 is 55, so that'd be 55x, and it's positive. And 3 times 2 is 6, so that'd be 6x, and that's positive. And 3 times 11 is 33, and that'd be a positive. So when we put them all together, we get 10x squared plus 55x plus 6x plus 33. You can see that the x terms are like terms, so we can add them together. So we get 10x squared plus 61x plus 33. So our answer will be 10x squared plus 61x plus 33. We've got to first of all work out the equation of the line given to us. And it's horizontal, so it's going to be a y equals line, and it crosses the y-axis at 2.5. So it's going to be the line y equals 2.5. Now there are lots of different inequalities that would involve the line y equals 2.5. We've got y is greater than 2.5, y is less than 2.5, y is greater than or equal to 2.5, and y is less than or equal to 2.5. So we've got to work out which one of these it is. Now when we've got a dashed line, it means it cannot be equal to, so that gets rid of these two. And if we pick a coordinate, let's pick this one here, on our region side, it is 8, 8. Now look at the y coordinate, which is 8. That is actually more than 2.5. So it's not less than 2.5, it's going to be more than 2.5. So it's y is greater than 2.5. So we're going to first of all find out how many potatoes were below 22 grams. So we're going to draw a line up at 22 and a line across, and that is 13. So there are 13 potatoes below 22 grams. And so to work out the probability of picking one below 22 grams, it's the amount that we have below that amount, or below that weight, over the total amount of potatoes, which will be 20. So it'd be 13 over 20, which is equal to 65 over 100. So that would be 65%. So sometimes it's easier just to do a quick diagram to see what's going on. So I'm going to say that the house is here and the shop is here. And so this person is walking to the shop, and then they walk back from the shop, but they don't walk as much. And we're looking to see the maximum distance the person is from their house. So we're looking to maximize this distance here. So we want this distance to be the biggest it can be. So we can see that we want to maximize this distance here, so that the shop is a long way away, and we want to minimize this distance here because we don't want them to have made that much distance towards their house, because we want to maximize that distance. So we're going to find the maximum for the 3,750. So it's to the nearest 10, and a trick you can do to find out what the upper bound is going to be is just half the accuracy, so 10 meters to the nearest 10, half of that would be 5, and then just add that on. So that's going to be 3, 6, 5, 5. That's the upper limit. We want to minimize this distance, which is 120. So the accuracy is still 10 because it says both measurements are to the nearest 10 meters. So we're going to halve the accuracy. 10 would be 5, and this time we're going to take it away. So 120 take away 5 would be 115. Okay, so to find the maximum distance the person is from their house, we're just going to do 3,655 take away 115, which will equal 3,540. We're asked to solve this quadratic, and we're told that we're going to leave the answers to 2 decimal places, so chances are we're using the quadratic formula. So for the quadratic formula, we're we're going to use a, b and c. We'll go find a, b and c. A is the coefficient of the x squared. Now, we don't actually have a number before the x squared. Well, we kind of do. There is a 1 there, we just don't bother showing it. So a is 1. B is the coefficient of the x, which would be minus 15. And c is the number left over at the end. We're going to write down the quadratic formula, but instead of a, b and c, we're going to feed in the values that we've got. So it's minus b. Always put them into brackets. Plus minus square root of b squared. So I always put a, b and c into brackets, because here if you don't have the brackets it will square the 15, then put a negative before it. It won't be correct. And I just put brackets for each of the numbers. So 4 times 1 times 6, because if you put brackets around all of them you'll never ever have that problem. And then 2 times 1. Put that into our calculator with a plus there, and you will get the answer of 14.588 blah blah blah. Go back on your calculator and change that to a minus. Most calculators have cursor keys. You can go back and delete it and change it, and you get 0.411 blah blah blah. So to 2 decimal places our solutions are 14.59 and 0.41. In this question it might be easier just to draw a quick diagram. So let's draw this equilateral triangle, and it says that its lengths are all 10 centimeters, and we're looking to find the area. Now we also know with an equilateral triangle all the angles are 60 degrees, so we can plot those, but we don't need to plot them all, we can just plot one of them. And we know that to find the area of a triangle, we can use this formula here, which is half AB sine capital C. And if we have a look at this diagram, we can label the sides. So I'll call this side, this angle C, and little c here, and little a here, and little b here. So let's put that into our formula. Little a is 10, little b is 10, and sine c, which is 60. So with a, b and c, it doesn't matter what you label a, b and c, as long as the angle is opposite the side with the same letter. The angles are all capital letters, the lengths are all lowercase. Okay, so let's put that into our calculator and we get the answer of 43.301 blah blah blah. It says it wants it to 2 decimal places, so that is 43.3. We can write the equation of any linear graph as y equals mx plus c. So m is the gradient and c is the y-intercept. So we've got to find what the gradient and the y-intercept are. Well, I'm going to first of all try and figure out what the gradient is, because we're actually given some clues here. We're told that the line is perpendicular to the equation given. Now I'm going to rewrite this a little bit just to make it a bit clearer what the gradient of this is. So I'm going to write this as minus 1 over 12. I'm just going to leave a bit more of a gap there. Minus 1 over 12 x plus 12. And you can see that the number before the x, the coefficient of the x, is minus 1 over 12. But we're not told that it's parallel to that, so it's not, the equation that we've got is not going to have the gradient as minus 1 over 12. We're told it's perpendicular. Now, when two things are perpendicular, to find the gradient of the other one, if we know one of them, you've got to change the sign and find the reciprocal of the fraction. So to find our gradient, we're going to change the sign, so it's negative, so our gradient is going to be positive, and we're going to flip it. We're going to find the reciprocal. Reciprocal of 1 over 12 will be 12 over 1, or just 12. So the gradient of our line is going to be 12. To find the y-intercept, we're going to use the points given to us. So we've got x equals 3 and y equals 4 for a point on our line. We're going to substitute those into the equation we've got. So it's going to be 40 equals 12 times 3 plus c. Put in our solving lines. 12 times 3 is 36. And we're going to take away that 36 both sides. So it's going to be 4 equals c, or c equals 4. So our equation will be y equals 12x plus 4. First thing to notice is we actually have two radii here. So we've got this radius here and this radius here. And all radii are always equal in length. So we have an isosceles triangle here. So this angle here is going to be 19x as well. And we've got to write that down. So we're going to say angle OBA is equal to 19x. And the reason is it's an isosceles triangle. Okay, so we know these two are equal. Well, we also can work out x because, as I said before, we have a triangle here, and all angles in a triangle add up to 180. So we've got 7x plus 19x plus 19x equals 180 degrees. And this is angles in a triangle. Try and draw a better triangle, equal 180 degrees. Try and write out these reasons in full. Okay, so that's going to be, was it 45x equals 180, and let's get our solving lines in. And we're just going to divide both sides by 45. Okay, so we've got x equals 180 divided by 45, which is 4. Now, we're looking for this angle here. That's angle ABC. Now there's a few different ways we could do this. We could work out what this angle is, because it's a big triangle, etc, etc. Or we can use the fact that we've got a tangent touching a radius. So we know that this, let's just pick a different colour, this angle here is 90 degrees. So we can write that down. So angle OBC equals 90 degrees, because it's the angle between a tangent and a radius. Again, make sure you write all the reasons in full. And so therefore, angle ABC, which is what we're asked for, it's just 90 take away the 19x. Well, we know that 19x is 19 times 4, because we know that x is 4. And so that would be 76, so in total it would be 14 degrees. So angle ABC is 14 degrees. So we're told that y is inversely proportional to the cube root of x. And to get rid of this proportionality sign here, we just convert it to an equals and times the right hand side by k, which represents a constant. And we now need to figure out what that constant is. So we're going to feed in the value of y and x that's given to us in the question. So we've got 10 equals k over the cube root of 343. Okay, next thing we're going to do is we're going to solve that. So put our lines in. Now the cube root of 343 is 7. So we can actually just, it's a lot easier, and we're just going to times both sides by 7. So k equals 70, and we're just going to rewrite this, but instead of k, we're just going to write 70. So y equals 70 over the cube root of x. Whenever you're asked to work out a proportion of items in a histogram, you can actually do it by just counting the squares. So in the first bar, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 squares here. The next one, you've got kind of 4 half squares, so that will be 2 squares in total. And then we've got 4 squares in the last one. So altogether we have, for the amount of squares, we have 12 plus 2 plus 4, which will be 18. So it's 18 squares in total. Now it says that we're looking for between 25, which will be here, and 45, which will be here. So we count the squares in this little interval. So there are 3 here, and there's half a 1 here. So the squares between 25 and 45, I should say dash 45, 25 to 45 is 3.5. Okay, so we've got 3.5 in total, or 3.5, out of a possible 18. So we just need to do 3.5 divided by 18 to work out the proportion, and that gives us 0.194 blah blah blah. It says it wants its 2 decimal places, that would be 0.19. Whenever we add fractions together, we want the denominators to be the same. So if we've got 2/3 plus 1/2, to do this we can times the 3 and the 2 together to find the common denominator, which is 6, and we can times the left hand fraction by 2 to get to 6, and the right hand fraction by 3 to get to 6. Now with algebra, okay, we've got some algebra here, but the process is exactly the same. We're going to times the left hand fraction by the x plus 2 and the right hand fraction by the x plus 5. So we're going to times the left hand fraction by the x plus 2 first, so 3 brackets x plus 2, and that's going to be over, and we're going to times the denominator also, the x plus 5, by the x plus 2. And we're going to add that to, we're going to times the right hand side by the x plus 5, which is the denominator on the left hand side. So that's going to be 9 brackets x plus 5, and that's going to be over, and we're going to times the x plus 2 by the x plus 5. I'm just going to do it in the same order as on the left hand side, just so we can see they're the same. Okay, now the denominators are the same, we can add the tops. I'm going to do kind of 2 things at once here. I'm going to add the numerators, but I'm also going to expand the fractions at the same, expand the brackets at the same time. So 3x plus 6, expanding the first bracket, plus 9x plus 45, expanding the right hand bracket. So we can simplify the numerator now, and we can have 12x plus 51. 3x plus 9x, which is 12x, and then 6 plus 45, which is 51. We don't need to do anything with the denominator. We can leave that as a bracket. We could expand it, but the question doesn't ask us to. And if the question doesn't ask us to, we don't need to. If we were to expand it, you'd get x squared plus 7x plus 10. As always with this type of question, we want to get rid of the fractions or brackets if we have any. Here we've got some fractions, so we're going to start by getting rid of them. I'm going to start by copying down the question, and I'm going to give plenty of space, because these kind of questions do get out of control quite quickly. And so we've got 2 over x plus 10 over x plus 10, and then we've got equals 7. So I'm just going to scroll down and just give us lots and lots of space. Put my tram lines in for the equals. Okay, first thing I'm going to do is I'm going to get rid of the fraction on the left hand side. I'm going to do that by timesing everything by x. And don't forget, it's not just both sides, you've got to times all the terms. So we're going to times the first fraction by x, which will just give us 2. Times the second fraction by x. Well, when you times a fraction by something, you times the numerator. So it would be 10x over, and it would be x plus 10. Denominator stays the same. And here it just becomes 7x. Next, we're going to get rid of the second fraction's denominator. So we're going to times by brackets x plus 10, both sides. Okay, so 2 times x plus 10 is just going to be 2 brackets x plus 10, but I can actually just expand it now. 2x plus 20. Then it's going to be 10x, because the times x plus 10 just gets rid of the denominator. And then here, let's try and expand this as we go. And so we do 7x times x, which is 7x squared, and 7x times 10, which is just 70x. Next step we're going to do is just move everything on the same side. Now I normally keep the x squareds positive if I can, so wherever the x squared is, I move everything else to that side. So we're going to collect the 2x and the 10x, and we're going to take away 12x from both sides. So we've still got that 20 on the left hand side, and here we have 7x squared, where is it going to be, plus 58x. I'm going to take away that 20 from both sides, because with quadratics, to solve them, we always need it to equal 0. Right, now, little hint in the question, it says, write your answer to 2 decimal places. That normally means we're going to be using the quadratic formula, and looking at this question, it doesn't look like we can factorise it. So, quadratic formula, we need to know what a, b and c is, or are. A is the coefficient of the x squared, which is 7. B is the coefficient of the x, which is 58. And c is the number on its own, which is minus 20. The quadratic formula is x equals minus b plus minus the square root of b squared minus 4ac, and all of that over 2a. So, putting in the numbers, it would be minus brackets 58, and I always put brackets around these, because if they are negative, it makes it a lot easier and a lot more reliable. Minus 4 times the 7 times the minus 20, and all of that is going to be above 2 times the 7. Okay, so we type that into our calculator with a plus, first of all. So you get your calculator out, type all that out, and you should get 0.331, etc. And then on your calculator, you go back to that plus and change it to a minus, and you should get minus 8.62. Oh, hang on, that's not quite right. 8.617, blah, blah, blah. Rounded too early there. And then when you round those, you should get 0.33 to 2 decimal places, and the other one will be minus 8.62 to 2 decimal places. And looking at that, to answer this question, we're going to do something a bit weird on the calculator, and this is a method you might not know, but it's the quickest method for answering this question. And what iteration basically is it's feeding the previous solution into the iterative formula to get the next solution, and you keep going, and it will get closer and closer to an answer, and then we write down that answer. But on our calculator, what we're going to do is just press the button 1 and then equals. Now what that will do is it will store the 1 that we have here in our calculator. Then we're going to type in the cube root button, and the 1 will disappear. That's not a problem, because the next thing we're going to press is answer plus 10. So on your calculator, it should look like this: the cube root, and then answer plus 10. When we press the equals button, what will happen is it will work out what the next number is in our iteration. So if we press equals, we get 2.22398, blah, blah, blah. Because we're looking for it for 3 decimal places, we're just going to work that out to 3 decimal places. So it'll be 2.224. Then all we need to do now is press equals again, because instead of using the 1, it will use the 2.223980091, etc. as the answer. So I'm going to press equals again, and lo and behold, I get 2.304. Press equals again, 2.309, equals again, 2.309. Now, when you get the same answer twice, you can stop. That is our answer. So our solution is 2.309 to 3 decimal places. To be able to find the inverse function of f of x, to find inverse, which is what this -1 here means, we're going to start off by just replacing the f of x with a y. And to find the inverse, all we do is we swap over the x and the y. So I'm going to do it on the right hand side, so we've got a bit of space. So x equals 2y minus 12. And then the task is to get it so that it's y equals. So we're going to first of all add 12 both sides. So it's x plus 12. And then we're going to get rid of that times 2 there by dividing 2 both sides. And so the inverse function of x is x plus 12 over 2. So we're going to need to complete the square to be able to answer this question, but the first thing I need to focus on is this 2, the coefficient of the x squared. I want to make sure that x squared doesn't have a coefficient or has a coefficient of 1. So we're going to start off by just removing or dividing out that 2. And we're going to do it from the x squared and the x term. So we're going to be left with the x squared plus, and that's 14x. And we just leave this plus 5 at the end. That plus 5 really only ever comes into use at the end. Now we're going to complete the square here. So that will give us brackets x plus half of the x coefficient, which is 7 squared. And I'm just going to expand that quickly here. So x plus 7 squared is the same as x plus 7, x plus 7. And when we expand that, we get x squared plus 14x, which is good. And then we get plus 49. Now this bit here is the bit we need to remove. So what I'm going to do here is just take away that 49, because we don't really want that 49. Close bracket, plus 5. Okay, now I'm going to expand these brackets and have the 2 next to the x plus 7 squared. And 2 times minus 49, which will be minus 98, plus 5. And then all we need to do now is add the minus 98 and the plus 5 together, which should be minus 93. The m part will be the 2, the p part will be the 7, and the q part will be the minus 93. So to find the shaded part of this diagram, we need to first of all work out the volume of the smaller cone, which is at the top, then work out the volume of the larger cone, which is the whole cone shown, and then take them away from each other. So the radius for the smaller cone is 4 and the height is 5. And the radius for the larger cone is 20 and the height is the 20 plus the 5, so it would be 25. So I'm just going to label them A and B. And so why don't we work out the volume for B first? And the formula for the volume of a cone is 1/3 pi r squared h, with h being the perpendicular height. So it's 1/3 times pi times 20 squared times 25, which is going to be 10,471.975, blah, blah, blah. We're going to work out the volume for A, and this time it will be 1/3 times pi times the radius now is 4, and the height is 5. So that will be 83.775, blah, blah, blah. So to work out the shaded bit, we're just going to do the volume for B, take away the volume for A. So it's going to be 10,471.975, take away 83.775. And all those I'm going to keep in the calculator to keep the accuracy. And that gives us 10,388.199, blah, blah, blah. And to 2 decimal places, it's going to be 10,388.20. Here we've got a cubic graph and we're asked to find out what the equation would be if it was in this form here. So first of all, notice that we've got a negative cubic. A positive cubic looks like this. So we've got a negative cubic, and there is a minus sign there that just deals with that. So we don't need to worry about the fact it's a negative cubic, because that minus sign just means it's negative, fine. Next thing we want to do is find the roots. So the roots are where the line crosses or touches the x-axis. So here we can see it touches it at 6, so when x equals 6. And here, now this is an interesting one, it actually touches it twice. It touches it at -7 the first time going down, and then it touches it at -7 going up. So there's technically 2 roots there. Sort of one root, but it counts twice because it's going down on one route and then up on the other route. So with these, what we need to do is we need to make sure that at x equals 6 and x equals -7, that this equation, the whole thing equals 0. So if we imagine A, what does A have to be to make this whole thing equal 0 when we look at this, the fact that a root is at 6? Well, if we put A at -6, we get x -6 in that bracket there. And if we put in the value of 6, then it's 6 minus 6, which is 0, and so the whole thing is 0, because anything times 0 is 0. So if A is -6, let's have a look at B. So what does B have to be? Well, if that's -7, if we put B as +7, then when we substitute in this -7 here into the x, we get -7 plus 7, which is 0. So if B is -7, then the whole, +7, then the whole thing will be 0 at x equals -7. And for the C, we're looking at that last root. Again, it'll be the same, won't it? It'll be x plus 7. Now, you might ask the question, how do you know which is A, which is B, which is C? Actually, it doesn't matter. We could put A at -6 and A at 7 and B at -6 and C at 7. As long as one of these is -6, 1 and 2 of these are 7, you'll always get the right answer. So I'm going to first of all just draw out the diagram a bit bigger, just so we've got a bit more space. And we're looking at going from B to M, and M is about here. Now the first thing to notice with M, I'm just going to quickly label the other parts on, is that the ratio of A to M is 1 and M to C is 4. So the ratio is 1 to 4 between the two. And what is really helpful sometimes is just to label in the kind of section. So if A to M is one section, we've got 4 of the sections from M to C. So just put little notches there to show the 4 sections. And we can see straight away that A to M is 1/5 of that distance. That's why it's a nice, easy way to show that A to M is 1/5 of that distance. Let's just put a nicer 5, there we go. And so we're looking at going from B to M, but we can't go directly from B to M. We've got to go from B to A to M, and that's going to be the direction of travel. Now, we don't know the name of the road between A and M. In fact, we don't know the name of the road between A and C. We've got to first of all work out what that's called. So what we're going to do is we're going to go from A to C by going down here and then up here. So we can find out A to C is going to be going backwards down A, then up B. Now A to M is going to be 1/5 of A to C. Now, if A to C is minus A plus B, that means A to M is going to be minus 1/5 A plus 1/5 B. Now we're asked for the vector B to M, and we know that that's going to be B to A plus A to M. We know B to A because it's labelled, it's just A. and we know a to m because we've worked it out down here. And it should be minus, let's get rid of that, because we know it's going to be minus 1/5 a plus 1/5 b. And so a minus 1/5 a is going to be 4/5 a, and then we've got the 1/5 b, so it's going to be 4/5 a plus 1/5 b. A simple trick when you're finding the inverse of a function is to replace or to switch the y and the x. Now we don't actually have a y in here, but we can just put one in, it's not a problem. So we can just rewrite this function as y equals x over 10 minus 11, and we're just going to switch around the y and the x. So x equals y over 10 minus 11. Now the objective now is to get the y on its own, to make y the subject. So we're going to first of all add the 11 both sides. And I've made an amateur move here. I've not left myself enough room, so let's just scoot that across. Okay, so add the 11, so it would be x plus 11 equals y over 10. Next thing we're going to do is multiply by the 10 to get y on its own. So it would be 10 brackets x plus 11 equals y. Expand those would be 10x plus 110 equals y. Now this doesn't equal y. We are looking for the inverse function with this notation here. So we just replace the y with this notation and we get 10x plus 110. So then you can complete a unique version of this paper by going to our OnMaths site. OnMaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.